pretty much the talk is finished now, so thank you very much. No, I really wish to thank a lot Farah for coaching me and leading all of this talk, and especially the graphic designer who helped us in doing something that looks nice. So a big applause to Jill as well, and yeah, thank you. So the talk of today, the title is very, I guess, is very unusual. The real title is about the future. How can we use the new technology for our future in a good way? Or is there a good way to use the technology for our future? Is there a hope? The reason why there are so many things in the title is because I want to find different topics or different areas that could be linked together in a single story, let's say. So the story is about artificial intelligence and how artificial intelligence can be used in what we do, and the story is about art, is about music, is about design, architecture, computer science, a bit of everything. It's like a big Italian pasta. So if we speak about artificial intelligence, we cannot start but from Alan Turing. Everybody in UK knows him, and even abroad. Alan Turing was a prominent scientist, a great solver of a very complex problem during the war, and he was a great mathematician, and one of the first person that formalized the idea of what is artificial intelligence and how to find out what it is and how to test if it works. So starting from his work against the German, now we are all together in the same Europe, so it's good. At the time we were not, so he was trying to solve a very deadly machine, which was this Enigma machine that was able to, through a mechanical system, to hide information from the enemies. And the way to solve that machine was to create another machine, the bomb. And the bomb was a big computer, essentially, but it was a mechanical computer, something that today would make us laugh, like a giant room full of gears and things that spin, but that is able to solve very complex analogical logical sequences. He was trying to find out the probable letter in a word based on a lot of statistics and a lot of things that would be difficult to do with MATLAB. I did that with a machine. So there was a lot of thinking, really a lot of deep thinking about mathematics and logic that brought him, after the machine was made in the 50s, to write a paper. And the paper was about artificial intelligence and can a machine think? Because if a machine is able to solve a very complex logical problem, can a machine really think? Can this problem be solved by intelligence? So there was a lot of debate about this, obviously, because thinking is not just solving a problem, it may be something more. So he concluded a bit like Blade Runner, saying, can a machine imitate people? Can we have a machine winning at the imitation game, where you don't know, actually, if it is a human or a machine talking to you? And if you have seen Blade Runner, you know what I'm talking about. So the question is then, can we have a machine design, and can we see a design from a machine and be puzzled and think, oh, maybe it's done by a human? That's the question. Okay, so sorry for the interruption, abrupt. This was Johann Sebastian Bach, many of you recognized. Is the beginning of his masterpiece, I think, and many think, which is a collection of music called The Art of Fugue. It's a sequence of several musical pieces that are structured for growing complexity, from the simplest to the most complex. And the most complex because Bach used something which is called counterpoint in English, and it's the capability or the ability or the structure in the music when you intersect several lines of music in a very, very beautiful harmonic structure, which is rich from a complex point of view. So now there is a joke from by Glenn Gould about this that says that Bach indeed he was a misunderstood genius during his time. Nobody really bothered about him so much as we do now. And he's saying it's not because he was ahead of his time, but because he was thinking generation behind, like 200 years ago, more or less. So Bach was composing music using this counterpoint was really popular in the 1500s, so Renaissance time. But he took it to a level of complexity and beauty that are like far, far beyond what people of 200 years before could do. Nevertheless, he was not somebody typically Baroque. So if we look at his music, we take something from a well-tempered clavier, the harpsichord, and we look at the music score for whom doesn't read music. I make it simple with a graphical sign. That sign is the first line of music. It's the first voice entering and playing a sequence of notes, which you can imagine as a geometry as well, or like just a sequence of sound or a data sequence. But then there is a second voice who plays exactly the same music at a distance, and they play together for a short while. And then again, there are others. So the whole harmony of the music is made with a lot of lines that intersect each other in a very complex structure. And if you look at the second page, then you find the same structure also with a longer time. So it's an intersecting structure of the same shape with the same rhythm, but also with a different rhythm. So it's really, really, really clever design. So when I was studying the piano and I was stopping collecting insects, my father bought me a T-shirt. It wasn't this one, but similar. And I wasn't clearly David Bowie at the time, so otherwise I would be rich. And this T-shirt said, "Architecture is frozen music." That is a word by Goethe. And I kind of didn't understand at the time the meaning of this phrase. It looked cool, so I was at class, and then one day a professor picked on me, "Oh, what, I've got the T-shirt. Do you think it's true?" And I was like, "Yeah, sure it's true." But then he started questioning why it was true, and then I got in trouble. He was not the one of structure, though. It was somebody else. So it was another, I swear I'd never do that again. Anyway, so jokes aside, what Goethe said is very true, because then I realized, studying history of architecture, that if you look at the Renaissance compositions, the architectural composition of Palladio, for example, and you think at the back of music of this complex structure, harmonic structure, and you start looking at the church, like, I don't know, Palladio's Redentore in Venice, you can hear the music of Bach because you start looking, and we have the first line, and then there is a second one, and then there is a hidden one, which you can hint only by the little element in the facade, and then there is another one. So this architecture is the same as music, and it really looks the same, it sounds the same. So architecture and music are the same substance. One is frozen, the other one is liquid. Anyway, so the other thing that I realized Bach and Palladio, or the architect, many architects, had in common is the fact that they are widely copied by the successors. So if, for example, Palladio, the Vicenza Rotonda, is copied here in UK by Isaac Ware, it's not really copied, it's inspired by, you can say, he takes and takes to beyond the same ideas. Then the same is true for Bach. Bach wasn't very influential at his time, he was out of fashion, nobody really wanted to copy him because it would be unpopular, until very recently. And very recently we have a lot of jazz music that takes from Bach. For example, Jacques Lussier or others that play Bach on every sort of instrument. But what is very interesting is that Bach is also copied by a computer. And a computer that has a program, a software that is written by David Cope, who is an American musician. And what is particular about this software is that the music of Bach is completely done by a machine. The machine takes bits of the music of Bach, combines them together with a slightly different material, and generate a sequence of notes that sounds like Bach music. And Bach music isn't easy to write. So for a joke, David Cope as his friend, they did a little competition and they said, okay, let's try. You write your own version of Bach music, human-made, you know, like, and I write my own with a computer, and then let's see what people think. So they went to a campus of a university, they tested that, and surprise, most of the people didn't quite like the human version of Bach music. Maybe the composer wasn't very good, but maybe the machine was very good. So if we think about that, we think that maybe architecture with rules can be written by a machine as well, the same as music is, because music is a very, very intimate art. It's not like something cold that you can kind of put in Excel. It's very complex. To the point that Hofstetter, who read the book, I suppose liked it a lot. It was about Gödel and Bach and Escher and the interlink between mind and art and mathematics. And he thought that at the time he wrote the book, it was not possible to write music with a computer because music requires feelings, requires experience, requires you to know the life. But then when he heard the music of David Cope or his program, he thought, well, maybe music is as much as I thought before it would be. Maybe it's not such a big thing. It's not, maybe a machine can do it. So anyway, seems like music, it's possible. Definitely pop music, trust me, no problem. But what about strategy? Can we have a strategy made by a machine? Can we have a machine thinking like properly, like Napoleon, for example, like a big Cray computer doing a Napoleon strategy for us? So if we start looking at video games, and then we look something like an old one, like Space Invaders, we don't think it's possible because it's a bit going right and left, and that's it. It's not very intelligent. Then we get to other video games when they became popular, more about strategy. So Football Manager, it was not about scoring and playing with the player, but it was about the strategy of the game. You could choose the team and yeah, whatever. I don't even know if this team still exists. Then at the end, the result of your strategy was a game, but it was about the strategy, and the computer was playing back the strategy, but still it's soccer. I mean, soccer is not so difficult. At the same time, there were movies saying, we are in the 80s now, they were saying, oh, wow, my God, now if you take people, people have emotion, that's a problem, so let's take away from the game, that part. You are left with logic. So a machine playing logic will be our solution to World War III, where the missiles go this way and the other way, and it will do everything for us. It didn't happen, luckily, but something else happened, and it was the famous match from 1997 with Deep Blue and Kasparov, where Kasparov lost. Well, no surprise, a machine can do like a million variations in a second. I mean, the fact that he lost by half a point, for me, is incredible. He's really a good guy. But, I mean, it's really, I never beat the computer. I only beat John Waite. I mean, the thing is, though, what it was shocking for Kasparov, and it's still a matter of debate, is that during one of the game 2, the machine made a strange move. Instead of going to hit a pawn, he moved strategically. So he did something that is not an immediate beneficial move. He did something that was good in the long term, that somebody thinking and analyzing the complex structure of the game would do, not somebody that is driven by an optimization algorithm that says that's the best move because you get 10 points now and you grab it. And he thought that somebody cheated. In fact, he said, well, this is like it was then in 1700 when there was a supposedly intelligent machine with a guy inside that was playing chess and moving a puppet. But we don't know that. Maybe the machine really made a move. Maybe the machine really thought like a human would be. And if you think about Turing, the question is, can a machine write music like people would do? Well, it does. Can a machine think like people would do? Well, maybe it does. So there are like signs that things are going to change. Another thing in sport, like something like baseball, Bill Bain in 2002, he had a very low budget and he said, well, shall I try to win the championship or shall I just surrender to be like number 10 in the league? I don't care. So what he did, he threw away every rule of thumb, every kind of acquired rule of the game, and decided to implement a statistical analysis of the players and what they would do together in a similar team and minimizing the cost. He did this very, very like artificially, very courageously, because the results were unknown. I mean, you are going to depart from the known way, you are taking a big chance. In his view, he did nothing to lose because he was already like in the middle of the league, no money, so what's the point? Well, what he did, he succeeded. So he got like second, won 20 games in a row, so using mathematics, logic, analysis together is good. So what if we take all of this intelligence and we take it to the next phase, and we take it to the table of our the decision-making table, and instead of using our guts and our experience or our suggestion, We use artificial intelligence to help us, not to decide, but to provide scenarios for our decision. Because when a chess player is fighting against the other champion, he does use a computer to train. He's not ashamed of that. The computer is just a machine, who cares? But the computer can test a lot of different scenarios very quickly. So when you sleep, the machine can think, and in the morning you can see, okay, the machine tried a million scenarios. This is going to happen. Okay, I don't believe the machine, let's try. Or, I think the machine is right. I want to see what happens. And you go ahead and you do it. So what we could do is to play our own design with a machine. So everybody is the king from his perspective. So no worries, there is no name of who is the king. For example, because time is the biggest problem we have. When it takes like 6 months for a design process to be completed because of all the complication in talking to each other and this and that and so on. If we set up good rules, if we set up them intelligently together, we can save a lot of time and we can all agree on a solution. And maybe it's a good one, maybe not, maybe we wasted 1 day, but not 6 months because the computer is fast. So 1 day, well, look bad, then we have 6 months to think about. So if we decide to take the leap and go for it, then we need a series of tools. And obviously we need to describe reality with a set of parameters. So how do we describe a situation? How many people are going to be involved in this decision? 10 people, 5 people? How does it look, the building? Is it like a big building, a small building? Is it like a triangular building, and so on? So we look for parametric design. And with parameters, we can define very complex structure already. So you can have BIM or even more complex structure. It doesn't have to be a building. It can be a situation, like a chess situation. Once we have parametric design, we need the optimization of it. And we need the optimization because we need to know which option is better than the other. There are criteria. Maybe it's difficult to say which one is better because there are many different criteria. But there are ways to tackle that problem. One of them, and don't call me cynical, is the no free lunch theorem. Sorry, I didn't invent the title, but it's a very important theorem in optimization that is about the fact that you cannot approach a problem always with the same tool, because after a little bit it's going to fail. You need to be prepared to use a lot of different tools to approach a problem. One of them, for example, we developed together with Christina Shi, Gianni Bosfor, and Andy Sedgwick here in 2004, was end colony optimization. The method is not ours, we implemented it for a project. And the way it works is very simple. If you think about insects and the way they move, and you have like a big cake, the ant goes towards the cake, the ants leave a little bit of pheromone, which is like a smell, when it goes towards the cake. If the ant is successful, the brain of the ant says, go back to base, so it comes back. And he comes back to the same route because he can smell it, so he can smell the route he did. So the next ant will smell the same pheromone trace and will follow the first one, most probably. So if the ant is able to get to the food very quickly, then from something that is very fuzzy, where you have all the ants going everywhere, you start having emerging behavior of all the ants going to the same objective. And eventually, they will get to what they want, which is an optimized solution. I mean, these guys, though, they have to probably do the salesman problem and find a very quick route out. So, but this is still not enough. I mean, you have like optimization and parametric. Okay, we have done that since 2004, and everybody is doing that now, but it doesn't matter. We need also data, because if we have an intelligent machine, we need the memory. And data, we have a lot. Everything we do is always data. Emails, files on the computer, at the supermarket, in the CCTV camera, everything is data. We can measure temperature, humidity, everything. It's like the brave new world. But if we collect this data, and we organize it in a way that the data is nice, is crisp, is not like a lot of rubbish data, but is significant data, then we can use something more. We can use the ability to learn. And if we plug the data to the ability to learn, which is an implementation of some type of logic, could be neural network, could be like probability logic, subjective logic, whatever, name it, then we have something that can look at the previous situation that are alike the one we are in, can look at the parameters we have, find out which one is the most performing option, and tell us what to do, or what the consequences of what we do are. So if we combine everything together, and we put together our choices, we can have something like artificial intelligence which will reorganize the way we design. Now, this talk is not meant to tell you what to do or what we are going to do. It's meant to give you an option or an overview of what is possible. Now, it's up to us to think what we want to do it and open a debate about this, because it's going to happen. There are a lot of signs that artificial intelligence is around us. Even in the telephone, you speak with Siri, it's about the same. So it's going to be there. It's up to us to see what to do with it. Thank you. So if you want to ask any question, I have the machine set up. You can ask and we'll answer you. Obviously, it doesn't speak. I'll speak for the machine. Yes?
Where in the world do you think the first artificially designed building will be erected?
I don't know. Anywhere there is a will, and well, maybe not. Maybe it's cheaper. You never know. I mean, this is, as I said, this is not necessarily a good future. Maybe it's a terrible future, but it's going to happen. So it's up to us to make it a good future. If you think about the Industrial Revolution and the movement about art and crafts being destroyed by the machine that makes the cup of tea, and now we all buy the cup of tea made by the machine. Well, could we stop that? Maybe not. But still we value the art and craft. So it's a very complex subject. And I don't know where it will happen, but it will.
Well, what do you think the clients, the characteristics of the client need to be to buy into that?
Client will have to be a machine.
Not necessarily. I think sometimes you need somebody visionary and with a very strange problem. For example, at the Olympics, to say one, we were helping to sort out the lighting in the venues that were not quite so good, and it was for broadcast. And one of the problems was flicker, and the flicker was, I don't know if you know about flicker, but basically when you use a super slow motion camera, you can see almost like the explosion of the glass and all the shard. But you can also see the light going on and off with the electrical cycles. So it doesn't look very nice when you have the champion dark, bright, dark, bright. So they said, how can you fix that? And to do that, it's either you spend a lot of money in electronic ballast, which is a kit, or you select which offset between the wave of every fixture in the venue you want, so that is minimized, the ripple is minimum. If you do that by hand, it will take you like weeks. But if you write a software to do it, it takes you like 6 hours. And it works. So this is the type of problem. They didn't ask us to do it with a computer. They asked us to solve the problem. It's up to us to use the best tool. So.
A question. In movies, there is obviously the emergence of the thinking computer, and the dilemma is always this good versus evil transition that seems to occur. Could you expand on that a little bit and explain why we're fascinated by this notion of good and evil?
Yeah. Well, I mean, it goes back to the music, I think. It's like I'm an emotional guy, so I speak with emotion. When I think of music, so I take one step back. So you have a very high opinion of somebody, and you think this person is really, really good. Then one day you hear this person talking, and it doesn't make sense, and you think, oh, maybe it's not so good. And it's such a hard feeling, a very big disappointment. And sometimes you just decide not to see what you're seeing. So going back now to your question. When you hear music made by a machine, and it sounds like Bach, and you think, wow, Bach was so good, and blah, blah, and then you hear this made by a stupid machine, that hurts your feeling. That's why you think, is he evil or is he good? I don't know, it's annoying a little bit. But it does happen. I hope I answered your question. Yeah.
Yeah, brilliant talk. I think the interesting for me is that architects really think the parameters for what you put in your artificial intelligence need to come from outside our discipline, from medicine, from science and others. How ready do you think the industry is for that level of sort of allowance of that to come in and influence how we design?
Yeah, the industry probably isn't that ready, but you said it. I think that's one of the advantages because, and this is already with the optimization is possible. So when you use the optimization, like for example Johnny Bosfor in his project, you have to have this open approach, that you define the rules, and then the machine does what it has to do. But obviously, defining the rules isn't easy, so you will have to ask to the doctor, to ask to other people, to people that are outside of your own strict circle, and accept what they say. And obviously, with a parametric model, with something that can be shaped in an efficient way, see what the solution is. If it doesn't look nice, throw it in the bin and try again. But definitely, using multiple discipline and extending it to something outside of the building industry is one of the advantages of artificial intelligence. So it's a very good question, and thank you.
You raised the interesting subject of different countries. How do you see different cultures affecting this form of thinking?
Okay, let's go back to the parallel with Industrial Revolution. I think it's like with everything. Some people like to explore the innovation because either they are bored of what they have or they have no chance to be happy with what they have, so they want to go ahead and try. Some others just follow when they see that it's ready and working well. So I don't know which country is which exactly. Some more traditional country maybe will be not really so keen in this way of doing. Maybe other will be faster in adopting if they see a very good return. But you can tell some countries are definitely more practical. The culture of the place is more about it has to be done, it has to happen, rather than we talk a lot and nothing happens. So I expect, like, where efficiency is one of the value of the people, this will happen. Where efficiency is not something important, then there is no really driver for it. It's already good, it works.
I thought it was magnificent, the talk, very insightful, very well presented obviously, but great storytelling and very enjoyable to understand the issues. I think that we're in a very disruptive age. I think I started to predict the end of the industry, but I think the smart, intelligent people will be in control ultimately of the future. So yes, we'll work with machines, but very smart human beings will ultimately be in control, I hope.
I thought it was very interesting. It's good to hear lots of different disciplines coming into the thinking about design and how we make decisions. I think it's really, really exciting. I think it would be really interesting to see how that actually plays out in terms of what a piece of design would actually look like. But I think that's an excitement yet to come, probably.
I thought it was a talk that I will think about for a long time. It's more about giving us many ingredients and try to think what it means. The question of AI in general is an open-ended topic for me, and I think Giulio was right in not trying to give all the answers, or try to. So yeah, it will get me thinking for a while with happy thoughts.
Oh, it's exciting. I think actually it's a good start to the day. I think that's the best way of putting it. You know, you wake up in the morning early to come for a breakfast meeting. You never quite know what's going to come off. But that has given me a boost, actually, selfishly. I think it's an interesting debate, but selfishly, I just bloody enjoyed it, you know. So.